So needless to say, a ton of time and money goes into the production of a movie. And so the point of this project is to be able to create a model that helps advise producers and directors during their decision-making process about what kind of variables they need to pay extra close attention to before they pursue a project and during the production. And so using a variety of our data visualization, business intelligence, and correlation analysis techniques, we have discovered that it looks like the number of users voted, duration, number of critics for reviews, and Facebook likes for a movie seem to have the most impact on being able to represent what exactly went into a movie's particular IMDb score. And so we want to further analyze these variables to create a model that not only illustrates the factors that went into a movie's particular score, but be able to predict a movie's future score, like a movie before it has been produced, to help directors and producers know whether or not they should pursue it at all. So first, our regression techniques. So when using the test and train data for linear regression, it was definitely not a good model given our mean squared error and R-squared values. This means that there was a huge dispersal of data points around the data set's mean, and that there was an amazing amount of variance between your estimated points and your actual points. And so running a multiple regression analysis on the data, we used all 4 variables, and looks like the R-squared isn't particularly good either, probably about as good as the last one was. If you'll notice, this is the value for collinearity between all the variables. And so this is when one X variable can be predicted by the presence of another. And so this is a huge problem because it undermines the statistical significance of the independent variable. And so then by testing IMDb score against just 2 variables, the R-squared value actually went down. And we still received the warning of multicollinearity, but it was admittedly smaller than it was compared to the test with 4 variables. And so I think it's important to note that even though multicollinearity is by far preferable to avoid, it seems a little unrealistic to assume that we can erase this at all, given how large and complex this data set was. And so at this point, we just are going to recognize that multicollinearity is a characteristic of the data set, but we will still continue to create other models to see if they better fit the data. Using a lasso technique, we did not get much help out of that for all the variables. Coefficients are strikingly small. And so the duration is marginally larger than it was for linear regression, but it is still not a good model. And our mean square error and variance for the lasso technique is not preferable either. So therefore, we're not going to use this model. Using recursive feature selection, we found out that duration and number of critics for reviews seem to be the most significant in predicting a movie's IMDb score. And we had observed some implications of this earlier, but this is just further evidence of that. But running them in a multiple regression analysis didn't look promising. R-squared is still considerably low. Using random forest regressor. So this is the kind of result that we're looking for. The mean square error was considerably lower than we've seen before, and the R-squared was amazingly higher than what we had been receiving before as well. And so this tells us that about 88.458% of the variance between the dependent variable and those dependent variables can be explained.